All right, well, welcome everybody. Today's session is on I guess I kind of called it just data life cycle, really wanting to just cover all the different components of data in ARM and kind of split it across two different webinars. So we'll cover kind of the first chunk today, and then next week we'll do the second half. So today, starting at the beginning of putting in data into ARM. So we'll do the data entry and describing the data as it goes in, then talk about data confirmation of making sure what we're putting in is what should be in there, and then also kind of summarizing that data just at the level of putting in some transformations and some calculations using the action codes. And then next week, we'll get to the kind of get our hands dirty in some statistics, kind of looking at the analysis side of things and doing data review will be what we cover next week. So with that, let's just get going here. So I'll kind of be toggling back and forth between some slides and an ARM. The first section here is pretty much all just in ARM. To cover the data entry. Pretty straightforward, not a lot to discuss, but just more of showing what we can do here. So I'm going to begin in a trial. I've just got a trial from our tutorial study list. That is the one I'll be using. And so as you open up a trial, the most basics here in the assessment data editor, each assessment rating that you perform is going to be its own column in the editor. And so here we've got 3 assessments already defined. If you're receiving this trial for the first time, that's kind of an indication that these are what are planned for the trial and things that have to take place. Of course, we can always add our own. So I'll just kind of walk through an example of that. So maybe in my case, I could either start typing in column number 4. Oops, I'm just clicking randomly here. Start typing into column 4 to just create another assessment. Or if I wanted to insert it more chronologically, I could always right-click in a column and insert a data column. And so that will put one here right in between 1 and 2 and give us a brand new column number 2. I am going to go over to my properties panel. I notice I've only got a little bit of information about my pest and nothing about the crop. So I want to change my view. So a couple of ways to do that. We can really control what components of our description for our assessment we can see. And so you can either use this hidden field section, which will show each row that currently is not visible. If we wanted to turn on, for example, just the pest code, that would be a way to see just one more line. In my case, I must have been playing around with that a bit, and a lot of the fields I want are hidden. So I'm going to use the built-in views and take hidden fields with information. So anything that is currently hidden but contains some information I want to be able to see. So I'm going to select that, and that adds a bunch of rows here to give us a little better glimpse at kind of at least the typical pieces of information we'd fill in. So just kind of talking through the thought process as we fill in an assessment. We'll just say we are going to do a phytotoxicity rating of the crop after an application. Maybe it's a week after the application to see how the crop is doing. And so just to begin, I guess with the pest information, in my example, we're not rating anything to do with the pest. We're focused on the crop. So I would leave the pest section blank and move on to the crop area where we would then fill in our crop. And so I could either hand fill it in, or I do notice that my column 4, I've already filled in the crop once before. So to take a little shortcut, I might just grab a few rows of information and do a copy. So that way I don't have to hand type all that in a second time. I'll paste it in, and that will bring in all of those rows together here in my assessment column number 2. Then the description, I think we made mention of this a couple weeks back. The description used to be training that would be a great place to put a free text, just a nice short description of what the assessment is. Kind of the easiest way for a human to read it, even though we were definitely going to still use all of the other fields to be more explicit. However, we cautioned that the description is actually just about the crop. So we want to use the SE description, and I need to go back and update my, my example files so they use that SE description as well. So this is really the best place to describe the assessment that we are doing. And so in my case, maybe it's just something as simple as, we're doing a crop FiGen, if I could spell, and it's one week after application. Whatever kind of freehand notation you want to use, just to make it nice and readable, perhaps, as to what we're doing here, essentially. Moving on down, we kind of have the heart and soul of the assessment description here. I would say these 3 rows are really the core of any description for an assessment that you're performing: the part rated, rating type, and rating unit. And so the part rated would be, what object, what is it that you're looking at, rating, counting, performing an action on? Whatever the case may be, it's the object that we're really zeroing in on. And in my case, we're really looking at the entire plant. So I'm going to bring up the validation list, and I'm just going to start typing the word plant, and sure enough, we have a part rated called plant. Of course, depending on specifically what it is you're looking at, there's a lot of different options, but in this case, we're really taking that plant in as a whole. So I'm content with just using plant as the part rated. And then there's a second value here, C or P, really referring to the crop or the pest. In some cases, it might, you might not be clear based on the rating type you're doing. So we want to point out specifically, we're talking about the plant of the crop in this case. Now the rating type, that's really the action that you perform. Is really what I like to think of it as, the what and what are you doing. And so again, if we look at that list, I've got a small list of my favorites of ones I use most often, but if we look in the master list here, there is a large number of them, as you can imagine. If you're not wanting to just scroll and read every single one, if you just right click in the description column, you can do a filter to search for a keyword. So maybe I'm going to search for phyto, knowing that that's kind of the main action I am taking. And turns out we've got a wide variety of phytotoxicity, just depending on if you want to be specific about what type you're looking at. We also have a general one. So that's the one I want to use in this case. But if you're taking a variety of different types of phytotoxicity, you can see we have no shortage of options. So that is the what that we are performing. Then the rating unit would be the unit of measure for that action that you're taking. In my case, it's pretty straightforward that we'll be doing a %. That's already in my favorites list, so I didn't have to search very far for that one. And you'll notice with the %, we actually automatically filled the minimum and maximum as well. That's kind of a recent addition to ARM within the last year or so. That defines the minimum and maximum values for when we're filling in the data down below. So if you're doing a rating scale of 1 to 5, or it's a pH, so it can only be between 0 and 14 or whatever, some rating units, if we go back to our full list, some rating units actually have a minimum and maximum kind of predefined. Otherwise, you can always hand type them in too if you have a limit to your unit that isn't just automatically filled in. Then the next one here would be sample size. So in our case, not particularly important. We're just going to kind of give an estimate across the entire plot. So this first value is just the number, and then my unit here is going to be plot, the most basic. Really, if there is no subsampling that's going to occur, then I think the sample size would typically be one plot. Definitely though, if you are doing assessments that have subsamples or some sort of system and description as to how you should sample the plot, then that sample size can be very useful. And in fact, there's a couple of other fields related to that, the collection basis and the reporting basis. Those are usually hidden by default just because they're not used in every situation, but for subsampling, they can be very helpful to be explicit about what you're doing. If you're in that case, I won't cover all of it now, but if you look in the help, we do have a reference document on that for describing subsamples in assessment data. And so that'll just pop up a PDF that'll walk through a variety of subsampling examples and kind of talk about how to utilize, for example, that collection basis or the reporting basis. So that can be handy if you are doing subsample work. So that's about it for my example. There's a few other fields, just depending on the type of assessment that you're doing that you could take advantage of. But certainly, that kind of covers the core, at least idea behind filling in the assessment. If you're new to this and sounds like that was quite the process anyway, I do just like to let people know that, as you're looking through these lists and trying to choose something, there's not so much like a right and wrong answer that you could find in this list. I think the key more is about consistency. Choose something that is clear so anyone else reading that would understand what you chose, lines up with what you were performing, but it's not that you can really make a wrong choice, but make the same choice each time you do a phytotoxicity. Choose that same option. We kind of talked in a previous webinar about SEs, and that's really the idea behind that is to standardize and actually use the same description every time by saving it to a file. So that's one of the keys there for that feature. All right, so now we've described that assessment. We can get on to the actual entering of the data. So just kind of real quick, real basic, filling it in. It's much like you would put in data into Excel. So here I'm in plot 101 and I can type in my value. If I press the enter button, it will move down to the next plot. If I press the tab character, that will move over to the next assessment in that same plot. So much like you would see in Excel. So right now I'm sorted by plot number. If you want to match maybe a little more closely to how you would have moved through the field and taken your notes, you can do that by the little shortcut buttons here. A second from the bottom would sort the plots by your assessment order. And this last one with the equipment there will sort by harvest order. And the assessment and harvest order, those are defined on the trial map. So this button in the middle here kind of is pointing us to that location. So on the trial map, there's a movement arrows tab at the bottom. And you can just describe and define how you would move through the trial. So you can see these arrows. Right now I have it set as serpentine within blocks. So we would start at 101, work our way down to 106. Then we will go up to the next block and start at 206 and work our way back. So it wouldn't make a lot of sense to go all the way back to 201 and just walk down the field again. So try and be a little more efficient and then jump to 301, work our way down and up and over to finish off at 401. There's quite a few different combinations that you can specify here, just depending on your trial and how you would move through it. Really the same idea for the harvest order. It just gives you a chance to choose a different one. So, maybe for a harvest, it is a different, a full equipment going through the field. So maybe it might be a totally different direction and system to it. So we kind of just have the two different options, although they really have the same choices you can make. So that assessment order, you can then sort by. Again, either this little shortcut button here to sort by your assessment order, or we have the sort here in the toolbar up here, a sort by assessment order, harvest order, be another way to kind of get to that. And here you can see now we'll go down to 106, and then the next one will be 206. So if I'm just cruising through and jotting down my values, then it'll be in that order that I perhaps took them. And it'll just continue, you just hit enter and it'll continue to go in that direction. For an assessment, so far we've just been typing in values, but if you look on the properties panel to the right, you can add additional information for any of these plots for this particular assessment. So in this assessment section here, there is just a free text comment that you can put in here, typing in whatever extra information you may want to include with that value. There's a barcode you could record. There's GPS coordinates that you could put in if necessary. You can attach an image to that plot specifically for that value. And there's also a check mark here for damaged. And so that will drop this value from the analysis. So it will be treated as if it's a missing value. And if I click away, you can see when it's marked as damaged, there's a strike through. So visually, we can see that that 12 here is not going to be included in the analysis, although it still lets us put in a value for a record keeping. There's also a red triangle that will pop up if you put in a comment or a GPS or an image, one of those types of things. Here, I'll put in more text over on this one just to show there's more information here than just the 22. So when you click into there, you can see that additional detail. And back on that subject with the damaged, if you have a damaged plot where you don't even have an assessment value for whatever reason, the best way to put in a missing value would be to use the period or the dot. That's the way to tell ARM. ARM again will treat this plot 204 the exact same way as it did 205, that there's no value there, it's a missing data point. But the period then shows that you specifically don't have a value. As opposed to if I just left plot 203 blank and kept putting in my values, then if someone came back later, you're just not quite sure what happened to plot 203. Did somebody just forget to type it in, or is it supposed to be blank? So that period there is really the way in ARM to say, hey, it is supposed to be blank. So we don't have anything to count there, but I am kind of marking that as such. Just a couple of quick keyboard shortcuts if you're doing a lot of data entry. One trick would be to use the single quote key. And here I pressed it and it already did it all at once. So I'm going to type it over here into the comment. The single quote there is the key I am pressing. And when you put that while you're typing in data, it is going to take the value immediately above it in the editor and put that same value in. So if I have a 10 and then I want to replicate that now, plot 405 is also a 10, just pressing that single button of that single quote copies the 10 from above and also presses enter for me. So I'm on the next value. Kind of in the same thread of keyboard shortcuts. If you type in the letter Z, that will give you a 0. And to do 100, you can either press the H key or the C key for centi. So 0 would be a Z. It's not letting me go down again. I'll just do this. C and H both give 100. So some common values if you have a whole column of zeros or hundreds, because there wasn't much going on in that assessment. It was pretty easy to just cruise through pressing those little hidden shortcut keys. There was one question, if we back up just a moment to the missing data or the damaged, what happens with the missing data when you have Yates or average checked for the ANOVA? So that is when we are doing our analysis, and I'll bring up the AOV means table real quick just to show the option here. So when we go to analyze the data, what happens with that missing data point? And so there are a couple of different methods for dealing with missing data when we go to try to analyze. And actually, the first option I would show real quick on that is actually it's going to depend on your analysis method. So if you are using the traditional AOV, then ARM will need to use some sort of missing data estimate system to essentially fill in that missing data point. We need to kind of guess what's a reasonable expectation for what that value might be, so that we have the same number of values in each replicate before we do the analysis. And so Yates is a particular calculation that can be used for figuring out that missing data estimate value, or the average will simply take the average from that treatment from the other reps and just use that as the estimate for whichever missing data point you have. If you are using the least square estimation analysis method, then that method doesn't use either of those two. It actually has its own way to adjust for missing data, really using an adjusted mean. Not statistically probably 100% accurate, but I have found it's pretty close to Yates. Like if you ran one report with the Yates and the traditional, it ends up being, it seems pretty close to the least square, although I'm sure it's not 100% always the same, but at least they're comparable from the little bit that I have seen in troubleshooting. But that's really what will happen in the analysis portion with that missing data. And again, all of those rules apply whether you use the damage checkbox to say throw out this value, or if you don't have a value at all and use a period. Both of those are counted the exact same with that missing data calculations. Great question. All right, final example for data entry. Of course, we just showed all the keyboard shortcuts, but we do have copy and paste support. So if you have data in a different file, probably the most common would be Excel. So we can copy and paste. So if I have a list of data values, I can copy it from Excel and I can paste into ARM. However, ARM is going to stop me and say that ARM can't help me at all with what I pasted in. I just gave it a list of numbers. So it can't verify that it's going to put the data in the right spot. So it's basically asking me, you need to make sure, are you in the right spot? You know, I'm here at plot 101. Should my numbers go right in starting there, and have I sorted my plots correctly? So I'm saying, yep, that looks good. That's exactly where I want it. I can say okay, and ARM will just put those numbers in right in order where I pasted them. Of course, that could be error prone if you didn't remember to sort your plots correctly, or something like that. Let me undo the paste here, and I have a better example. If you include a column of plot numbers, and I'm matching the heading with what is shown in ARM, if I include plot numbers, when I do my paste, let me go back to column 3 and do a paste. Now, notice that ARM didn't just blindly fire those values in where I had clicked, but instead it found plot 201 from my copy and put the number 2 right with plot 201, and made sure to put the data where it goes with the plot. So that's a much more foolproof way to put in the data, to make sure the software will just find where the value should go, instead of leaving it up to that human element of making sure things line up before you paste. And you'll notice there was no prompting when I pasted, because ARM knew right where things go. So there's no confirmation needed. It's very confident we can put things right where they belong. Kind of along that same idea here, you could also include a column with the plot and the treatment. But this is a way to actually update your randomization. So just a really simple example. Currently in my trial, I've got treatment 4 is linked to plot 101, and treatment 1 is at 102. But maybe in my real map, the way I want my randomization laid out, I wanted treatment 1 to be at 101 and treatment 4 at 102. So I'm really just swapping those two just to be very simple. But of course, you could do this for all of the plots in the trial and set what treatment should be matched up with what plot. So if I copy that, and I can just go into a blank column, it doesn't really matter where, because I didn't have any data with me in this example. Then when I paste, ARM is going to say that it has treatment 4 assigned to plot 101 currently, but what you're pasting, you have treatment 1 there. So are you trying to update the randomization? In my case, yes, that's exactly what I want to do. And so it will update the randomization here of what treatment is linked to what plot, which also shows up on the trial map. Their plot 101 is now treatment 1, and plot 102 is treatment 4. So that's a slick way. If you have already defined your randomization somewhere else, and you're going to create your trial in ARM, if you don't want to drag and drop and get that map to match what you had already decided on, you can use that copy and paste. And again, the trick was just to match the heading you see in ARM, and it can recognize block and column is essentially the X and Y coordinate of where that plot is on the map. So really, from a data structure standpoint, this information is what creates the map. So that block and column says first row and first column is where plot 101 is. 102 is still going to be in the first row, but now it's going to be in the second column, just creating a grid essentially. So that's really the randomization. visually in a map or just as a list. It's really the exact same information. All right, a couple of questions here. Referring to ANOVA again on the analysis, and there are missing subsamples. Does the average option make an average estimate based on subsamples in the remainder of that treatment? I'm not 100% certain of this answer, but typically when, let me just create, just to visualize here, an assessment that's got 3 subsamples. So we'd have something like this, and then a missing data point, and maybe this next one has got all of the values in it. So we've got multiple values for each plot. Typically in the analysis, what ARM does first is it's going to take the plot mean. So it's not going to send all of the subsamples through the analysis, but really the analysis is just going to see the plot mean. So as a result, I think it would effectively be the average option. It would really be the same, because in this case, this would be a 13. So whether we ignored that missing data and just took the average of the others, or if we did a data estimate and put a 13 in here just in the analysis, it's going to be the same. It's going to be the average in the end anyway. So yes, I think it would really essentially be performing the average estimate, if you will, just because you're going to have the plot average being used in the analysis anyway, where we don't send the subsamples necessarily through the ANOVA. And so then the second question about whether subsamples should be manually averaged within a treatment before entering it into ARM. I would recommend not. I think perhaps there's some practical reason why it should be, but if you can enter them in to ARM, the individual subsample values, I think that in general would be best if it's practical. That way the software can give that average instead of having, again, just that more human touching of the data, whether it's that mental creating an average or whatever. Just asking for unforced errors, if you will, with the analysis. Of course, if you're doing 100 subsamples, maybe it's a little challenging. I'm sure there's probably some situations where it's just becomes less practical. But I guess my answer to that would be probably you would find a practical balance of which approach would give you less chance of error. As the number of subsamples grow, perhaps there's a better chance of an error in handling all of those data cells in ARM. Maybe it's better to average them. Or on the other side, if it's just 3 subsample values or 5 or 10, we can handle it. It's probably better to have the software have every value. I would say more of just a practical approach. I think statistically, as I kind of alluded to in the first half, it would be the same because we're really not statistically at that subsample value level. So good questions. All right, so that about wraps up section number 1, I guess, of today's session on data entry. So let me find my PowerPoint again, and we will move over to our next section, which would be data confirmation. So this is a step that I guess I don't want to take credit that I came up with it, but I've kind of tried to separate it from data review. When I first, kind of lined out some training for people, I typically would hear just the term data review. We want to learn about data review, and we kind of lump all of the features together. And as I talked about it more, I kind of found that I was splitting that data review discussion into two parts. And so really, I wanted to give that first part a name. So I gave data confirmation because I think it's a separate step. And so that's really the goal here, is that, before we really consider analyzing the data, we need to look at what's been filled in. And so real quick before I dive in to what I mean by that, there was a question with the data entry rating shells. And so I guess I didn't plan for the rating shells. I could try to cobble something together towards the end if we have extra time on that to show the rating shells. So I'll jot that down. If we got some time at the end to squeeze that in, we can definitely try to show that a little bit, and maybe compare some of the data entry options in general. Might be a nice recap. So I'm just jotting that down, see if we can remember if we've got time to do that. So now that our data is in the software, we really want to just look at the data for what it is, not really thinking about the analysis or what the data means per se, but what do we have here essentially in that column? And so, really acknowledging that there may be outliers, kind of strange values that could occur. Maybe there's inaccurate values where we type something in incorrectly, or had a transcription error, or there was a smudge on the paper, so I misread it, something like that as well. So we want to be able to catch those issues, kind of right away when the data is in. So that way, once we are onto that next step, once we are putting in the analysis, we have that confidence that this data is accurate. So now, what is it telling us? It's kind of the next step. But let's be sure that what is present, what is here in our software, is the right information. So that's really the goal, our target here for this data confirmation. And so there's a few tools that we have in ARM for doing just that. So I'm going to close this trial since we just kind of have a mess and we don't really have any official data necessarily. I've got another trial that does have assessment values filled in here. I'll turn off my tutorial list to go back to my standard study list of files. All right, and so here is my data confirmation trial. All right, so I've got an assessment that we can say we just finished performing that rating on. And so just kind of walking through a few different tools, maybe in the order that at least I would use them, not necessarily most useful. In some cases, I think some might be kind of more useful than others. But I guess the first one we kind of mentioned already as kind of a newer option in ARM, the minimum and maximum to kind of define your limits. So in this case, it's a percent area is our rating. So perhaps we really would have a practical limit of 0 to 100, where there's no way that more than 100% of the leaf could be covered by our pest. Well, if we fill in the minimum and maximum, ARM can immediately alert us to a value that is outside of those limits. So this can be a good way to catch an obvious typo. In this case, I've got a 120. Well, clearly there's no way that there's 120% of that leaf was covered in our pest. So we can kind of identify that this value is not right. Well, of course, then we do have the trouble of knowing, well, what is right then? And so that's where I'll get on a soapbox a little bit to really highlight that hopefully this step can occur immediately after the data has been taken. The sooner that you can confirm that data and use some of these tools, the better that data can be. So depending on the situation, of course, 120 is not right. Well, what can we do about that? If it's a sheet of paper that we are referencing, we can, of course, look at it again and say, maybe we're lucky and say, yeah, it was just 20 written down and I just typed it wrong. That's the best case scenario. We can fix that issue and move right on. Or maybe that whole area is smudged and I can't really tell what it's supposed to be. Or we fill this in a Excel spreadsheet, or we don't have the person who took the rating to try to remember what had happened, and we're kind of stuck. We don't know what this 120 should be. I mean, we could take a guess and say, is it supposed to be 20? Or maybe it's a 12, or maybe it's 10. You really can't just roll the dice on what it is. So if it's after the fact, if it's too late, you're not at that site any longer, about the best you can do for a case like this, if you don't have the correct value, would be to use that damaged marker and throw that value away. Better than having the wrong value, of course, but now we're losing some statistical power, missing out on a value that could be there. So that's a big value for our data collection tools, to be able to do some of this review, leverage the machine and have some of these checks available to you, whether it's through the TDCX, the tablet data collector, or the ARM mobile as well. We'll do some of these checks for you. I think the rating shell might have a little bit of that with, I think treatment means are in there. You could maybe also do a find or something, I'm not sure. Depending on how savvy you are in Excel, maybe there's some tricks there as well to catch some of these things. But if you're still in the field, then this 120, we can immediately go right over to that plot and say, what is this deal? Did I just type it wrong, or what exactly happened? All right, so I'm off my soapbox, back to the technical world of using these tools. So that minimum and maximum gave us the opportunity to change that value if we knew the right one. In my case, I clicked cancel, so that way we could review and see what the problem is. I could go and find and scan down to find that 120. I'm actually going to leave it be to show some of these other functions. So let me just delete out our minimum and maximum. And if you did have the minimum and maximum filled in ahead of time, then it would be caught when you're typing in a value. Let me just steal this one here, even though it doesn't make any sense with the yield. So that actually when you were filling in the data and type the 120, as soon as you leave that cell, ARM would jump in and say, hey, wait a minute, that makes no sense. So if you do have logical limitations, if you put that in ahead of time, that can even help, even just in that process of filling in the data. So that's a quick one. Of course, doesn't always apply to your assessment. Really, I think the number one confirmation tool that we can use is the assessment map. And I think it's unfortunately maybe one of the best kept secrets in ARM because it's not very visible, but I think it really is powerful. So on the properties panel to the right, under the tools section, there is a button for assessment map. And this is going to draw us a trial map, but instead of coloring by treatment or replicate, it's going to shade in our assessment values from the column we are on and overlay those onto our plots. So ARM will take the smallest value in that column and the largest value, and then chop that up into up to 10 sections, and shading them. Smallest is lightest and darkest is highest. So that can be a really great way to visualize more spatially what has taken place with this assessment. And this is the trial map. So these are all just squares, but if you use the true scale option under the options tab, you can even have that map being drawn according to your plot width and length and the alley sizes that you would have in your trial settings. So this is maybe even more realistic look at that spatial effects that we have. And in my case, it's a pretty obvious that there's something going on with plot 904. Actually, if we double click on that cell, that will take us right to plot 904, where we can see, not a big surprise, that that 120 is giving us some grief. So a great way to spot a super obvious outlier by doing that. So maybe this will be the time maybe I'll actually adjust that. We can confirm that that's actually supposed to be a 20. Now I can go back to my tools and view the assessment map. And now I just casually change that to a 20, but of course, you want to make sure that is really the value before doing that. But at least to kind of show that this assessment map can get a little more interesting when you don't have such an extreme outlier kind of dragging everything across here. So now we can see a little bit more spatially what is happening here. If you click on a particular plot, here I'm going to click on plot 101, it's going to highlight and color only the different treatment 3s across the different replicates. So this is really the color by current treatment option. So it can be a nice way to just get a feel for that treatment's performance in the different replicates. How consistent was it? Here it looks like treatment 4 really struggled at the top corner, but was fine in the rest. Treatment 2 and treatment 5. So again, just another tool. Just as I click to different plots, it'll continue to highlight the different treatment, just that particular treatment across the map. And I can always turn that off here by just turning off that option down there to again see that full map. So this is available, of course, in ARM. It's also available on the tablet data collector because the TDC is really just running all of ARM anyway. And then we also have an equivalent in the ARM mobile app as well. If you weren't with us a couple weeks ago when we were showing that app, we have something similar. Instead of green, it's red, but otherwise it's basically the same idea for really visualizing that assessment. And if we had multiple, assessment columns that we had filled in, I could just press next column and that will draw the map for column number 2 now, which of course we don't have any data in, so there's nothing to draw. But that can be a handy way if you have multiple assessments that just got filled in, you kind of just essentially scroll through those assessments and review each of them as you go. So that wonderful tool there is the assessment map. again, it's kind of hidden there on that properties panel, but it's really a powerful option. Another one to show is right next to it on that properties panel, the box whisker graph. So this is going to graph that assessment column and give us a box whisker. And so if you're not familiar with the box whisker, really we're going to get a plot for each treatment in this column here. And the dashed line, it would be your mean of the data. That solid line there is the median. And then the box is defined as the 25th and 75th percentile. So basically half of the data is contained within that box. And then the rest of the data points create those whiskers that extend beyond there. Really giving you just a nice view of the spread of that particular treatment. So here treatment 1 is all between the lowest values at 10, looks like the highest must be about 35. As you can get a feel for that, kind of relative to looking at treatment 2, that box is a lot taller, so there's more variability in this treatment. And actually the whisker extends all the way down to 0, and there's one as high as 40. So there's a lot larger spread in that treatment. So that's a good quick visual of the variability essentially in each of those treatments. There is also an outlier calculation that is used for the box whisker, and those will display as an X if we have one. And here, if I hover over that value, I can see that plot 705 is calculated as an outlier. And that calculation is taking the height of the box, and then you would multiply that by 1.5. So basically a box and a half worth of height. If a value is that much distance away from the box, then we get an outlier. So you can see all of the other values in treatment 3 were pretty close, 0 up to 15. So that, not a lot of variability other than this one value that was way up at 25. So it ends up being that is considered an outlier. At least it's calculated as such in the graph. Wouldn't necessarily be a reason to just blindly go over to plot 705 and, oops, I moved my ARM here. We'll come back to that. Wouldn't be a reason to just blindly, mark that 705 as damaged, but at least it would be a good reason to go and review that value and make sure that it is valid and there was no typo or anything like that. If we're out in the field still doing this analysis, then we could take some more documentation, take some pictures or add some comments to note that something a little more unusual happened at this plot compared to the others. Another thing to just kind of look and visualize with the graph would be to get a sense of how skewed the skewness of the data, kind of leveraging those lines. So again, the dashed line is the mean, that's the average of the values, and the median is that 50th percentile, and that's the solid line. So for treatment 4, you can see that our median is a lot higher than the mean. I like to think of that mean is a little easier to move around if you have a high or low value that's moving things around. And so that's what's happening here, is that mean end up being pulled lower by a low value. So there's a 0 here that's kind of pulling that mean lower, although the median doesn't move as much. And so that really kind of shows that skewness I think that's negatively skewed, but I could have those switched around. I can't remember my my stats courses anymore of which way that goes. But again, that tail would be being pulled lower because of that low value. And so just kind of comparing the distance between those lines kind of gives that sense of skewness. And treatment 5 is kind of the exact opposite. We've got the median it's much lower than the mean. So it seems like there's a value kind of higher that's pulling that mean higher up than the median is at. So again, just some visualizations, I guess, to start to understand the data. Here in our data confirmation step, it's about making sure things are accurate, but it doesn't hurt to start to get a feel for what the data might be telling us. So that was the box whisker graph. Just real briefly, we do have some other, call them data attributes, I guess, either on the column properties panel. This one is starting to get phased out. There's some tools here that are kind of old that really are replaced by the column diagnostics. But I do kind of like this intro at the top here where it just gives some basic information about the column. In this case, it gives us the lowest and highest value. If we did have a percentage rating, then I believe that should get included. That gets included here as well as the min-max entry. So things like that to just get a feel for the data is on that column properties. And there's also an outliers calculator down here at the bottom. So you can get the very same box whisker calculation, but there are a few different ways that you could try to calculate and determine if a value is an outlier. And so you can use the standard deviation from the grand mean, whether it's plus or minus 3 standard deviations or plus or minus 2 standard deviations. Just a way to find unusual values to take a look at. And you would just do the find next button and it will move you right to that plot and show that value. Again, not a reason just to blindly, 65, that's an outlier, let's get rid of it. Is not really the goal of this. Even in a totally normally distributed set of data, you would have a few values. If you had 100, you'd end up with what, 5 values, I think it's 95% of values are within 2 standard deviations. So you'd still have 5 assessment values. If you had 100 plots, that would be flagged as an outlier here. So don't just toss them out just because of that, but it's a good way to find things that should at least be maybe reviewed again. Kind of the same idea on column diagnostics. I won't spend a lot of time here because we'll get to play around with this a lot in our next session on the data review. But just to point out that this top table with statistics, kind of similar to that column properties, there's just some, again, kind of attributes information about the data. So there's 50 data points, only 10 of them are unique. So we have a lot of similar values. So lots of zeros and tens, it looks like. How many are missing, how many are empty, how many are marked damaged, things like that. Could be interesting to see. I don't know how necessarily useful that would be in data review, but it's there in case it would be valuable. And again, those are just the different panels here all the way to the right. I've mostly been working with that properties panel here that have those tools. So those are the main data confirmation tools we did kind of already touch on in the data entry that damaged marker. So again, that would be a good tool if, as looking at this data, there's that 65. That was kind of odd. Again, we just because the data is unusual doesn't mean it's damaged or that it's unusable. So take all of those tools with a grain of salt. That if it's highlighting a value, that doesn't mean the value's wrong, doesn't mean it shouldn't be included, but it can be a tool to give a good target for review. Let's make sure this is accurate, things like that. But if you do decide that this is an invalid value, but you don't have the right value, or this is unusual to the point where it can't be included, that damage checkbox again over on your properties panel will discard that value, even though you have all of the documentation. In fact, I think especially in a situation like this where you've looked at the data and are making a decision to not include that value, that's a perfect reason to use the comment to maybe describe that decision as to why it should not be used. It's not just for your sake, but somebody looking at this trial again years later, or the sponsor that gets it back or whatever, to be able to see why that was thrown out. I think that's an advantage of data collection and using the tools that you have to be able to get as much documentation as you can, whether it's just marking your decision down, taking a picture, getting everything you can about that unusual situation that may have occurred. All right, so is there a way to exclude all data for a plot because there was like a sewing error? So this plot entirely, plot 105, let's just pick on him. That one, something went wrong and we can't use any of that data. At this point, we don't necessarily have like a way just to mark this as permanently damaged. You would instead do that for each assessment column. You can, so once you have everything in, or maybe even before, I guess you wouldn't even have to have a value in, you could certainly select more than one column at a time and then mark it as damaged. So that would probably be the most efficient way, is just drag across the different assessments you're going to take and turn on that damaged marker. And then if you're clearing it, you can clear those back. I think that would be the best way. So you go each individually to really exclude that plot. And taking that one step further, if you need to exclude a replicate, exclude a treatment, there's a couple of ways to do that, depending on at what level you would be excluding that. If just a particular assessment you need to exclude, let's just say replicate 1, total wash, something went wrong, we can't use it. There is an action code here in the non-analyzable data section. So we could exclude replicate, and then we'll tell ARM when we select ER which replicate we want to include. So take out that N and say, I need to exclude replicate number 1. And for just this assessment, all of replicate 1 will be marked as damaged. Essentially, it will be thrown out, it'll be treated as missing when we go to analyze. You can do the same thing for treatment. So instead of ER1, ET2 will exclude treatment number 2. Again, just for the one assessment column. If you're looking at across the whole trial, something is wrong with that first replicate, then that's an option in the print reports. Yep, Melissa is right on it. So in the print reports, this will cover the entire trial. You can say across all of the assessments done, this replicate or this treatment needs to be thrown out. You can do that in the general summary is where we will find the selected replicates. So then ARM will ask us in the next step, which replicates should I include? And so in my case, I would choose 2 through 4 because replicate 1 needs to be dropped out. If you want to do the same for a treatment, that's in the global report settings. The very first option there, print selected treatments. So let me just add the AOV means table just to show, because it will prompt us. So it's asking us which treatments to include. So maybe for whatever reason, treatment number 5 needs to be dropped from my analysis. I will choose just 1 through 4. Same idea with the replicates. It will ask us which replicate should be included. Since I turned that option on. Oh, right now it's asking me about my header lines. I'll just grab these 3. It doesn't really matter. There's our replicate number. So now we can choose replicates, again, 2 through 4 in our case, maybe. Oh, I've got a lot of replicates. I've got 10 of them actually. So 2 through 10, and I'll just drop replicate 1. So I suppose we can't really cross-reference the data, but we can see that treatment 5 is totally not here, and then the numbers wouldn't make any sense to us from the average perspective because we're missing that whole replicate. So that's kind of system-wide, across all of the columns, you can do it that way. All right, great questions. So we'll move on to part 3. And I'll try to go a little quicker. I'm just kind of glancing at my time and realizing that I've gotten a little heavy-winded. So I'll try to go somewhat quickly to cover what's out there and then slow me down when there's something of interest. Let's kind of take that approach here, because certainly covering kind of a wide range of possibilities here in these data calculations, and some of them you'll just never ever use because it's not the type of research you're doing where that calculation matters, and other of them might be super important and you use all the time. So just kind of going through the various kind of calculations that we can create. Once we've entered in the data, we can use that recorded assessments to create new assessment columns, some sort of summarization of that information. So my first example, dealing with subsamples. So we touched on them a little bit today. And really some of these calculations here, dealing with a column with subsamples in them, we can then use that subsample data, process them in some fashion, and typically what we get in the end is a new column of data that has just one value per plot. So kind of summarizing that subsample information down to one value per plot. So some of them are pretty boring, of just taking the average of the subsamples. We kind of talked about that. That's the default for when we do the analysis. So sometimes it might not even be necessary to do that if you're just trying to get an average to be run through AOV. That's what the analysis will do anyway. In some cases, though, you might want to sum them instead. So if it's like a yield of some sort, strawberries come to mind, that maybe you've got a bunch of you're weighing out the different fruit that's coming from that one plot. So you want a kind of a grand total of how much of that fruit came from that plot. So each of the subsample values should be kind of tallied together instead of averaged. So you can use the TSS action code. Calculating incidence, so that can be helpful if you're taking lots of subsamples and kind of just want to count up how many are zero. You know, the zero would, if you're zero, it means none, that there is no incidence. Then the TIO will basically give you a count of how many subsample values in each plot are not zero. And that would be that calculation. Kind of the flip side, if the 1 or really any number is really the none and you're looking for a 0, you're looking for the absence of something more or less, then the TII can be used. And so again, that calculated value for the incidence, it's actually a percentage. I think I misspoke a moment ago. It's a percentage of how many subsample values taken in that source column are, greater than that value. And then of course you can just count how many values are within a particular range. So just quick there, I've got subsample, I've got some examples here of just to show those calculations. So the source column that has 5 subsamples, so we did that percent area on 5 leaves. Then column number 4 has the TIO. So you can kind of play around with the numbers of how that would work out. 80% of my subsample values had an incidence. 1 out of the 5 was 0. So that's basically how that calculation is done. And then the T in is how many are between 50 and 100. So you can set whatever range you would want. Next category would be control corrections. And so there's a variety of these. And I'll admit, I usually get tongue-tied trying to work with these. It took me quite a while to get these slides right, because there's a lot of different combinations of these. First one to look at would be when you want to calculate your efficacy, really relative to the untreated check. Another term might be your percent reduction, might be another term to use for the same idea. And it's really in the calculation, then we're forcing the check to be 0. And then the rest of the values that we are calculating then is that efficacy of that particular treatment relative to the performance of the check. So starting with the Abbott calculation. So that one typically is used for like an infestation assessment. And the key would be if we can assume a mostly uniform population. That's really what these calculations are designed for. And so we have really 3 different flavors of the Abbotts. They all kind of revolve around TAB. Oops, I'm messing with my table here. So the first one, the TAB, would be your Abbotts. And we're calculating a percentage from the check in the same replicate. So our basis is really for each plot, we're going to have a different value. And you would want to use that if you can trust that your check is reasonably consistent across the different replicates. So really when you're calculating the value, I'm going to look if I'm plot 201 and I have treatment number 5, I'm going to find the untreated check in my own replicate and calculate relative to that. Now, if you have a lot of variation in your check across the different replicates, then you maybe want to really use the mean of the check across the different reps to calculate that efficacy. And so you would use this code instead. The @u tab would do that. So similar idea with the Abbott's, just a slightly different flavor. And then third would be the T tab. And so that is when there's really variation across the entire trial. And we're really taking the mean of each treatment, of a particular treatment, and comparing that to the mean of the check. So we really can't, we don't want to work just in particular replicates because of the large variation everywhere. So we really only get a unique value for each treatment. And there is a trick if you want, if that calculation is kind of valuable to you, not so much to run through AOV, but as a nice summary of what happened, the automatic transformation APC will actually be really convenient to have on the report. So this would be my control example. Again, an assessment with information in it. And now I've got a % of check. And so this was running the Abbott's on that. If I just sort by treatment, you can see numerically that check is 0. And now the rest of these values are really giving us a efficacy of how effective those treatments were in reducing compared to that check. Couple of other options. So there are a few more calculations in the same vein of efficacy calculations. There is a Henderson-Tilton. So that you will see the THT in the action code. That one's kind of designed for an infestation if you have a non-uniform population. And actually, you would take a pre-treatment assessment, and that would be column N, and then you would put in the column M, which would be your after, that would be the assessment after the application. So there's an adjustment that you can do for that. And then the Schneider-O'Reilly is another calculation, another option to use, kind of just industry specific, perhaps the type of research that's commonly, that might be the common one that's done in your area. That one's really mortality rating on uniform population is the main target, or at least what it was kind of created for. On the flip side, still looking at control corrections, but kind of doing the other side of the fence, if you will, to do a % of check. So really now we want the check plot values to be kind of our 100%, and then we calculate a percentage of that amount for our treatments. Kind of similar in structure to the Abbott's. We can look within our own same replicate and calculate per plot. Do that if the check is fairly consistent. The code would be @UPOC, would do this % of check is essentially what that stands for. And that's kind of comparable to that tab from before. Same idea, but again, instead of 0, it's 100. And is what the check is forced to, and we get the calculation relative to that. Same idea, if there's a lot of variation across the whole trial, now we're going to take the mean of the treatments versus mean of the check. So we're only having one value per treatment, and that would be the 2POC, I suppose. And you have an APOC option to have that value on your report. So hard to keep those all straight, but hopefully that just kind of helps kind of separate all of those because admittedly, it's a little bit of a mess in the just looking in the action codes. You can see they're all listed here and kind of given the names that we've been looking at, the Abbott. I like to just search for like control or untreated or something to kind of get a guess to see some of those options as well in the list. But yeah, they're a little bit of a mess because they're all thrown in there as all of the options. So trying to break them up a little bit. Again, we'll kind of try to cruise through here on some of these options, but slowing down if one's of interest. A yield conversion, this would take kind of your raw yield, your raw weight that you're taking from the plots, and instead of it being the amount in this one plot, convert it to a per area basis. So ARM has a lot of built-in calculations to do all the different types of conversions between various weight units to various areas. Within the dialog that we'll see in a moment, you can also do a moisture adjustment. So there's options to put those inputs in, and you can also even adjust the harvested area. So you can either just assume it's your plot size, width and length, or you can fill in a data column number. So you can fill in assessment column as just your plot widths, the harvested width and the harvested length. So if you did have some reason why you had non-standard sizes for the amount that was actually harvested, the area that was harvested in each plot, gives some granularity to that. So if I do that in ARM here, we can see we've got our yield in kilograms. There's also a moisture content. And so then we've converted to metric tons per 1 hectare. And so to do that, you can just start in the yield column, and in the tools, we can open the convert yield. And that's where we can input. We're starting with kilograms. What do we want? In my case, I had tons per hectare, but again, a variety of different options for where you're desiring to go. And you can just change the dimensions. Maybe it's a smaller area, but it's the same area across all of them. So you can adjust those values. And you'll notice what we end up with is just a conversion factor based on the units and the size. ARM calculates a conversion factor. And that's really what's done to calculate those final values in the yield conversion. So that's how we can convert then to whatever unit per area basis you may want. Some other ones, again, I'm not sure how common some of these might be, but we do have EPO rating scales in ARM. So this is a case where you can define separate assessment columns where you put in different classes. So in this, my example here, it's damage to plants. So there's a 1 to 4 scale. So there's different classes from 1 to 4 of how damaged the plant is from the pest. So in the first column here, column 10, we are going to count how many of our samples, our subsamples, were in class 1, which may be the most damage, maybe the least damage. I'm not sure which way it goes. Then we'll count how many were in kind of the second, third, and fourth. So this is kind of another way when we were talking about subsamples before. If you have to take 100 subsamples, there's other ways to maybe calculate. Instead of just doing an average, something like this, a way to record that, kind of tally up how many are in each category. And so if you have that structure, that way of filling in the data, now here are two calculations that you can perform. We can calculate a pest severity or percent incidence based on that structure of your columns. And so you would just tell ARM where the starting number is. So this would be knowing the 1 to 4 scale. So it knows we've got those 4 columns. And then it will perform the pest severity, which is really a weighted severity. So in this case, it's taking the group of ones. How many did we have in group 1 times 1? How many numbers in group 2 times 2? How many in group 3 times 3? So it were really kind of putting a weight to the higher class, the more weight it holds. So in retrospect, I think 4 is probably the worst then in that case. And so multiply it by 4 or divide to give kind of an average, but it's a weighted average then would be that calculation per plot. And then the incidence, kind of like before, in this case, it's how many weren't 1. So I think the 1 in this case, the scale 1 was actually 0. There was no damage in that case. And so let's count up all of the values that weren't 1, that did have some sort of damage to it, divide that by the total number of samples across the whole plot to give us the incidence in that situation. And I think those screenshots covered it pretty well here, but that's what I have in this example as well. Those basically counts or tallies for each class. And then we get those calculations just by using those EPO scales. If I open the list and clear my filter, let me go back in here. There we go. You can see that there's a variety of these EPO scales, just depending on if you're using 1 to 4, 1 to 8, whatever scale you may be using, the appropriate calculations are built in. So another option for subsampling. Kind of similar approach, but kind of the non-EPO rating scale. So in this case, we've got a single column that has subsamples, and that really is the class value. So again, if it's really kind of that 0 to 4 here, is what it looks like we're using here. So we've got multiple subsamples. The color doesn't show up well, but I think I've got 3 subsamples for us. So the 0, 2, and 1 are all plot 101. And so that would be, we had the first subsample was a 0, the second subsample was in class 2, and the third subsample was in class 1. So if you're just kind of filling in and recording it in that approach, then we have calculations that will do that same severity, a weighted severity, and an incidence as well. But again, summarized to one assessment column instead of putting kind of the class tally like we saw before in different columns. So another approach for subsamples. And so finally, just to go real quickly through the user formulas, we're about out of time here, but just want to highlight the possibility for creating your own calculation. So in tools and then transform. And these are some that we've already talked about, but down below there's a user formula. So kind of like in Excel where you just hit equal sign and you start typing the equation. We can do the very same thing here to create your own custom calculation. If I need to add columns 1, 2, and 3 together, if I need an average of these 4 assessments that I did 1 week apart, whatever you might want to do, there's that functionality to define a transformation of your own. So just to run through some of the options, we've got a help help page that you can read to see all of the options. But just real quickly, you would refer to an assessment column using brackets. So this would add columns 1 and 2 together, plot by plot, of course. There are some functions available like at average, you can subsamples, some things like that. Just press the F1 button or the help button in the corner, and there's a document that'll kind of step you through all of the options there. Limiting calculated values to positive and calculating one value per plot. If there are subsamples, you can play around with those options there to kind of change how those calculations are done. You can even kind of do a lookup for an untreated treatment as well. So in this case, this would take the assessment value in column 1 and divide it by the untreated, whatever untreated check value in column 1, then multiply by 100. So there's some power there. You can kind of reference and congregate the value, the information you might want to use in a calculation. So you can get fairly sophisticated depending on kind of what kind of calculation you might need. I won't really show any of these, but there are some advanced tricks as well. If you needed to, you can reference a header field, so you can look up, essentially look up above you to find like this sample size value if you needed to do that. So there's a way to be able to reference that value in a column. There's a match statement you can do to try to automatically determine which assessment columns to pull in. So if you were going to average all of the columns in this trial that had a rating type of bricks, you could do that using this calculation here. So that at match can really provide some strong capability to look up columns to use. And then there's even a prompting as well. So you could bake into that transformation. And when you use it, then ARM will prompt up, bring in a text box and put that text that you've entered in to have the user fill a value in specific to that trial. So I went through that really quickly, but just leverage the help button here. See if I can get that to pop up on, here we go. And just find the user formula down here, about halfway down. And that steps through a lot of what I just talked about really quickly, the different options to be able to build some pretty complicated formulas if you need to. And those calculations will be done much like we saw in these other examples where we were using action codes. The calculations are done one for each plot. And then we'll get to do the data analysis with those values, which we'll get to see next week. So with that, kind of ran a little out of time. Thanks for joining and hanging on for a couple extra minutes. I am available for a few more. If you were holding on to a question till the end, I'll try to remain flexible and answer any you've got if you have them. Or something like the data transformations. It's probably once you actually get into a trial and working on it that you might have them. So you can always reach out to Melissa or wherever your GDM rep might be. We can kind of help you through. A lot easier to I think through it when you actually have the data you want to crunch. So hopefully that was more of an exploratory what's out there that you can leverage there in the future. So again, thanks everyone for your time. Hopefully maybe we'll see you next week for our kind of our part 2 of our life cycle, if you will. We'll get to talk a little stats, data review, analysis options, things like that. So thanks again, everybody.
Thanks. Thanks, Matt. Thanks for helping run these webinars in a time that's suitable to us in the Asia Pacific. I know it's late for you, but I've had some feedback already on previous webinars and they've been really valuable. So thank you.
Awesome. That's great to hear. I'm grateful for the participation and the questions. It's nice to not just have me ramble through my set list, but know that we're covering things that help people out. So that's excellent.
Thank you.
Yep. Thanks.